lagi lah.
Okay, 1, 2, 3. Good afternoon to our lecturer, Sir Hazim Fahmi bin Muhammad Ghaffar. So today, before we start our presentation, I will introduce my teammate. So first one is Gilbert Clay Ana Abeng. Numbermatic is 20DEE22F1020. So the second one is Iklihan Maxis Anak Geramong. 20DEE22F1002. Third one is Muhammad Fadilah bin Abdullah. 20DEE22F1. Sorry, my bad. F1023. So the fourth one is 20DEE22F1018. So next slide. So for introduction, I will move to someone.
So today I will talk about the introduction of mechanical engineering. Technically, mechanical engineering is the application of the principles and problem-solving technique of engineering design to manufacturing to the marketplace for any object. Mechanical engineer analyze their work using the principles of motion, energy, and force, ensuring that the design function safely, efficiently, and reliable, or at competitive cost. In my understanding, mechanical engineer, that's because mechanical engineer career center on developing technology to meet human needs. For example, they create new things that can help to make a work faster and easier for us. Usually, every product or service in modern life has probably been touched in mechanical engineering some way that have human time. This includes solving this problem now there. For example, they have in healthcare, energy, that's all for me. Let's move to the other slide.
Scalar and vector in mechanical engineering. Vector are used in engineering mechanical to represent quantities that have both magnitude and direction. Many in the engineering quantities such as force, displacement, velocities, and the acceleration will need to be represented as vector for analysis. Vector quantities contrast with scalar value such as mass, area, or speed, which have magnitude but no direction. We move to the next slide.
So for the definition of scalar and vector, scalar and vector quantities are used to describe the motion of an object. Scalar quantities are defined as the physical quantities that have magnitude or size only. For example, distance, speed, mass, and density. Or the others. And however, vector quantities are those physical quantities that have both magnitude and direction, like displacement, velocity, acceleration, force, mass, and the other thing. It should be noted that when a vector quantities change its magnitude and directly also change similarity when a scalar quantities change. Only its magnitude change. So let's move to the next slide.
Okay, this is the formula that we're gonna use to find the angle. The name of the formula is the vector dot product, which is a dot is equal to the length of A times the length of B times the cos theta. If we want to calculate the angle between two below, we can simplify bring this vector length to the other side. of the equation, and we get cos theta is equal to A dot B divided by the product of the vector length. This is one reason the dot product is useful, as it gives us a great way to calculate angle without doing any trigonometry. Let's move to the question. The question 1 is find the angle between vector A components 2 to -1 and vector B components 5, -3, 2. This is the solution. First, let's find the length of each vector. For A, for A is 2 square plus 2 square, 2 square plus 2 square plus negative square, all under square root. We simplify to get 9 and take square root to get 3. For B, we get 5 square plus -3 square plus 2 square under square root. We simplify to get 38, and we just leave this as root 38. Then we move to the dot product, multiplying the corresponding components. We get 2 times 5 plus 2 times -3 plus -1 times 2, and we get equal to 10 minus 6 minus 2, and the answer is 2. So we plug everything in, we get 2 on the top over 3 times root 38. That is equal to the cos theta, and we try to solve for the angle. We just take the cos inverse and calculate by using a calculator, and the answer is at 3.80 degrees, and that's the answer. Next.
Okay. For the conclusion, I will tell you guys about the conclusion that we got from this mechanical engineering in Scala and vector. Vector have crucial role in our daily life as well as in engineering mechanics. Vectors are used to express quantities that have both a magnitude and direction. For analysis, many engineering quantities such as forces, displacement, velocities, and acceleration must be represented as vector. So based on what I know, scale and vector helps a lot in mechanical engineering because scale and vector help us to create something new. For example, we use a dot product to find the value of an angle. So you know that some of mechanics needs an angle of something that they want to do. So by using a dot product, they can solve a lot of problems that's they need to solve it. So Scala and vector also helps a lot in have transportation and other things that involve in mechanical engineering. So Scala and vector is very helpful to us, not also in mechanical engineer, but to us in every aspect. Okay, that's all conclusion from me. So that's all from us. Thank you.